In this video, we're going to take a look at linear functions. So that's just where we've got y equals mx plus b. I've just written the generic formula for a line of slope m here, and I've drawn a representative picture. Obviously, for this picture, both the slope and the y-intercept values are positive, but the algebra that we're going to do will work for any line. Now, lines actually have slope. The slope of this line is m, and since the derivative is trying to generalize the notion of slope, it seems reasonable that the derivative of a line should just be the slope of that line. The line that best approximates this line is itself. So it seems reasonable that the tangent line to a line is the line itself, and it therefore has the same slope. But let's just confirm that by going through the definition. So if I had a point x, the y value is mx plus b. And if I choose a nearby point, x plus h, every once in a while I like to just make sure that my x plus h is to the left of x, just to remind us that h is a signed quantity. It's allowed to be negative. Then what I'm doing is I'm replacing x, my input, with x plus h. So we would have m times x plus h, that quantity, plus b as our y value. Sure enough, the secant line that I get is the exact line that I started with. So f prime of x would be the limit as h goes to 0 of m times x plus h plus b minus, in parentheses now, mx plus b, because I'm subtracting the whole thing. I'm subtracting both terms all over h. So that's the limit as h goes to 0. Let's distribute that m. So I get mx plus mh plus b. And now let's distribute that negative, minus mx minus b, all over h. The mx and the minus mx will cancel. The b and the minus b will cancel. So we get the limit as h goes to 0 of m times h over h. Those h's cancel, and we do in fact get m. Kind of nice to see that if we are working with functions that already have a slope, the derivative, which is trying to generalize that concept to other types of functions, preserves the slope, so that the derivative of a line is just the slope of that line.